Hi, everyone, and welcome back to this Dash of .NET show. I'm really excited for this episode because we're going to learn something really new, which I've not seen anyone talking about recently in the community. And to deliver this great session today, we have Daniel, who is a Microsoft MVP and a senior software engineer. We have hosted him quite a few times in last 3-4 years, and I'm so happy to have him back. So without any further ado, let's bring back the rock star, Daniel. Hi, Daniel. Welcome to the Dash of .NET show.
Thank you very much. I'm very happy to be back.
Yeah, Daniel,
Um,
you look, I'll compliment you straight up. You look more fine than you did last year. You have changed your
it was
look. So,
pandemic.
oh,
That's an excuse. Hold on.
yeah, that makes sense, Daniel. So, Daniel, what are you going to talk about today?
Well, I'm very excited about this topic. I will
Mm-hmm,
talk about Microsoft Semantic Kernel. I
mm-hmm,
will jump in a bit and explain what it is. But nevertheless, I have the chance to talk about something very new because we just had the chance to see the final release last month.
mm-hmm. Yeah, that was really cool to have it released this month, and I've seen a few people, writing blogs and making videos around it. I'm so happy that you're going to talk about today. So, Daniel, I'm not going to take much of your time. Please feel free to go ahead and share your screen, and then we can get started.
Very well. Let me share the screen.
And everyone who's watching, you can find Daniel's social handles in the video description. If you want to follow him on Twitter, on LinkedIn, you can get all the details from there and reach out to him just in case if you need any help. I'm sure Daniel is very helpful. I mean,
Thank
that's what he
you.
does, right? He's a community guy. I see your screen. Yeah, that's your presentation. I'm going to add your presentation to the stream now. Everybody else can see your screen, and it's all you now.
Fantastic. All good? Okay. So, firstly, why semantic kernel? We had the chance to see some other frameworks. Um, for example, there is a library for consuming OpenAI LLM models, but that was more like a client. And now we are going to talk about an orchestrator. Semantic kernel is more than a client. It's not only sending prompts back and forth, but it's about using the power of AI to orchestrate some more complex scenario. So this is semantic kernel, and I will let you know in a bit what is. So it's an open source. That means you can contribute, you can influence what is developing there. And I have to tell you that in the last month, there were a lot of changes because the last month was just released. The final release 101 took place a few weeks ago, and until then, for about a half a year, there were a lot of changes. And why was that? It was because OpenAI had a lot of changes. They added function calling, they added assistants, a lot of features, and these had a direct impact on the development of this library. But maybe the most important part, it's that this library is for .NET developers. We had a chance maybe to see LangChain, but that was limited to Python and JavaScript, if I'm not wrong. But now with Semantic Kernel, C# developers, along with Python and along with Java, have the chance to use this power of large language models. This library is able to consume services directly from OpenAI, along with the Azure OpenAI, but not limited to them, because it's able to consume models from Hugging Face. And maybe, again, it's not very... Actually, I didn't check recently, but in the past, I had the chance to see that this library being abstract is able to consume on-premises model like Llama family models, and that's fantastic because you have the chance to run everything on premises in a silo. I don't know, in a sandbox, and play with it. So, as I said before, this is an orchestrator. And how is this um, completed? It's by using some containers for semantic functions and native functions. But what are these? We will see in a bit. Firstly, I would like to tell you that in order to build advanced prompts, we have here a syntax. And this syntax is able to work with some placeholders for using some variables or even functions with arguments. And that's very good because we don't want our prompts to be um, um static text. We are happy to make them dynamic, injecting some data in these prompts on the fly. So again, what are these plugins? Containers, where we can put and we can group together functions which are for the same purpose, for example. We can even mix native functions with prompt functions, but let's say we have um, a group of functions which are processing text. Yeah, we would like to put them together, like I don't know, string functions or strings plugin, whatever the name you like. And in the same time, we can use these plugins to keep some native functions. Let me get into some details. What are each of them? Semantic functions are text in, text out. It's a concept we had a chance to hear before, but it's like natural language functions, which are of course what large language models are using. But we are not limited to that because we know these large language models were trained using some data which are not very current. So in order to work with some real-time data, we need to do some, for example, some search on internet. And for that, we need some native functions to call some endpoints. Or let me tell you about some other scenario. For example, you have an API, and this API has some specific endpoints. We would like to be able to call them using HTTP client, for example. But there are a lot of out of the box native libraries, plugins, sorry, native plugins included in Semantic Kernel, and we can develop our own, which I will demo in a bit in this talk. So as soon as we have these plugins, we can use them, or we can export them in ChatGPT if we like, or Bing Chat, or Microsoft 365. Let me show you a diagram. So we have different plugins, and we can mix them together and solve some use cases. We are going to keep these plugins in our kernel. Kernel is a concept of this semantic kernel, which is the glue where we put together plugins and connectors and some other settings. And of course, we are able to call these functions. Of course, we can create the plugins in a programmatic way. But we are not limited to this. We can have some dedicated way of working with these plugins by using some special files. And these are escapeprompt.txt, which is in fact a JSON file which keeps um, information about the prompt um, and the variables used for this prompt. For example, when we try to get a response from a large language model, if we want to be creative because we are, I don't know, composing a poem or something, or a story, we want this LLM, large language model, to be very creative. Therefore, we would like to put the temperature higher. And if we want something which is precise, like generating Python or C# code, then we don't need creativity. We need preciseness. So then we will put temperature to 0. But there are some other parameters, and it's interesting to play with. And as I said before, we can put some information about the input variables. By default, we have the name input for input variable, but we can have more and we can customize the names. So in the right side, we have the prompt. As we can see, it's English language, but we are not limited to English. You can try playing with your native language. Why not? And inside, what is not so common are these double accolades, which is our dynamic piece of our prompt. Um, for example, the input variables, or we can have a function we are calling. There is another one here. It's a comment, right? So we have here a prompt which will replace this text with some injected data from comments and some injected data from input. Of course, I have used some other tricks in order to emphasize the most important parts of this input, but it's not the case to build here ideal prompt, but it's important to make it efficient. So having these semantic functions or prompt functions, let's talk about a little bit about the native functions. And as we can see, it's C# code. Similarly, we can have Python or Java. But please note, these three languages are not developed um, equally. So C# and Python are more advanced. I mean, Java may lack some features which are not there yet. This can be checked by visiting the official repository. And there you can find even a matrix with which features is available for each language. So let's take a look on this C# class. The native functions are easy to identify because they are prefixed by kernel function attribute and the description. And the description is very important because the name, actually the text in the description, has to be concise, to not leave um, space for interpretations. So if you have such class with kernel functions, keep there only the minimum of the functions you are planning to use with your prompt. and be precise and unique with your description, because the large language model will try to mix and match in order to identify which function is good for your prompt. So now I think I have to go a little bit in details. How are these used? For example, I have a robot car, and this robot car has a limited um, functionality. For example, it can move forward, backward, turn left, turn right, and stop. Basic movements, right? But maybe I want something more complex. For example, um, walk like a ballerina, or do a full turn, a complete turn, 360 degrees. And these are not very obvious how we'll map with the basic capabilities of our API. So something, and this is large language model, will have to figure out and break down this complex action into basic pieces. For example, if we ask our prompt to do moonwalk dancing, yeah, like Michael Jackson, uh, walking backwards. Well, I'm expecting large language model to break down this moonwalk dancing into some steps which are going forward more or less. And similarly, for ballerina, I'm expecting to break down this dance in some basic movements like forward, turn left, turn right. You know, capturing a little bit of this dance. Okay, so I think you got the point. I talk to my API telling a complex move, and the large language model will break down this complex move into pieces which are very well known by my API. And let's see how we can do this, because in order to break down this complex move in pieces, we have to do some tricks. We have to use some advanced techniques which Semantic Kernel is providing. And I will talk about function calling, and I will talk about planners. Planners are more it's they were introduced earlier, and they were responsible for figuring out complex actions in smaller basic actions or steps. But recently, OpenAI introduced the function calling, and these functions are some special functions which LLM understands in the large language model. Let me tell you an example. You can call the large language model with the prompt which asks for the weather in your city right now. And of course, the large language models were not trained by current data. So not a chance to know what's the weather now for your city. So you can add to your prompt some functions which are able to interrogate some API for the weather forecasting and for the daytime. And having these special functions which are like APIs. You can send these functions to the large language model. The large language model will try to identify your needs, and it will realize, okay, in order to respond better for this prompt, I have to send back a response to the caller saying I need to call first these functions which were sent along with the prompt. So as I said, the response is coming back with some, this time with some requests for these special functions which are running on the client side. They are getting some response, for example, the weather and daytime. And then they are sending back, look, it's a chat with the large language model. So the responses are sending back to the large language models, and this cycle is complete when there are no more functions to call, because a function can call another function. So in the end, this will be complete, and then the prompt will be augmented with the necessary information, and the large language model will respond with what you are expecting, like what is the weather in your city, and for this daytime in a human format. Yeah, not like JSON, which is the usual response from an API. Okay, now there are two flavors on function calling. For example, you can call these functions by setting the auto invoke on true. And this is making our code very simple. As you can see below, it's just a few lines of code. And let me explain a little. So at some point, we inform our kernel we are going to use motor plugin here, and then we are invoking this function. And lastly, and we are iterating through the responses. As I said, is a chat with large language models until all the functions are solved. For example, we may expect here to have more steps if we break down the ballerina dance. For example, go left, go right, forward, backward, whatever, and stop, whatever. So we are expecting here to see these steps which are figured out by this function inside the large language model. And of course, having these steps, now we can do something. For example, executing these steps on our side. Maybe you have a robot, like I call this presentation because I started from this idea to try to talk with the robot API. Yeah, we have in the end we have this car